All right, guys, here is the parallel circuit worksheet 3. This is question 1 off of that worksheet. And so, based on some of our values that we have here, let's see if I can just point out. So we know we've got 12 volts because that's what's given to us. And so we know at this point and this point and this point, we've got 12 volts, right? We'd all agree. We've been through this. Now, they want you to solve for the total current in this unit, right? So this isn't as complicated as it looks. The one thing I recommend is what we call the redraw procedure. So I'm going to go down here. I'm just going to draw this really fast. And what we're going to do is, you'll notice in this first set of circuits, we've got 2 resistors. We're going to redraw that as 1, because in a series circuit, we know, and that's what we've got here, from here to here is a series circuit. And each one of those is 8 ohms, so that would be 16 ohms, right? And then we're going to draw that next leg, and we're going to do the same thing here, right? Same thing. We got 16 ohms. And then once more here, we don't have to do much here because this is already reduced, and we got 8 ohms here, okay? So now we know that we've got to find out what the total current is that flows through this. So this is where our equation comes into play. So we go 1 over RT is equal to 1 over 16 plus 1 over 16 plus 1 over 8, right? And then we go 1 over RT is equal to 1, and I'm going to just keep fractions because we know 8 goes in twice to 16. So that'll be 2. And then 1 over RT ends up being what? Yeah, 4 over 16. And then we need the reciprocal of that. So that's going to be 16 divided by 4, right? And that goes in how many times? Yeah, 4. So we got 4 ohms. I'm sorry, guys. A little brain freeze there for a minute. So our total resistance in this is 4 ohms. So if we got 12 volts now, right? 12 volts, and we got total equivalent resistance in here of 4 ohms, right, throughout this circuit. We can see that that's less. Now we can figure out the total amperage. So 12 divided by 4 is 3. So we have 3 amps coming out, right? So once we know the total, we can figure that all out. And then, again, because you know that at this point, sorry, I probably should put the red, at these points we've got those 12 volts, right? You could figure this out. So if you divide 12, remember, just using Ohm's law, we can figure out how much current's going through this very first branch right here, right? And we would take 12 divided by 16, and you come up with 0.75 amps. We got 0.75 amps. And then we divide 12 for the last one by 8, and you ended up with 1.5 amps. And yeah, if you add all 3 of those legs together, what do you get? You got 3. So you know that your answer corresponds. These 3 values add up to 3, and 3 is what we got here, right, on that. So very good. All right, again, for worksheet 3, we'll look at question 3 here, and just get this kind of where we can look at it. So here we got to solve for the voltage, okay, which is fine. So let's just kind of work through this. We know that our total current, for example, coming up through here, it's saying is 6. So we know our total coming back here is 6 amps, right? We also have our resistances that are there. So the first thing that we probably should do here is, if we can figure out our equivalent resistance, then we can multiply that resistance times the amperage, right, using Ohm's law. It all comes back to that basic thing. So what we're going to do, I'm going to write up here, we're going to go 1 over RT, then that's going to be equal to what? Well, remember that we've got these circuits here. So I'm going to redraw this again, right? This just helps kind of keep you in a line. So there's my battery. And then I'm going to write this in as one resistor, right? And I'm going to have 3 paths like this. Okay. And then R5 was 4 ohms. Oops, and I should have put in, see, I got rid of those because I'm going to combine them, right? These two become, this is a series circuit. We're just going to add those two. So R3 and R4 was 2 and 2. So this becomes 4 ohms. That's what we do with a parallel circuit. Then R1 was 2 and R2 was 2. So this, what, we add those together, you get 4 ohms. So over here on our equations, we got 1 over 4 plus 1 over 4 plus 1 over 4. So 1 over RT, don't have to do any equations here, is going to be 3/4, right? And then we do the reciprocal of this, and that's going to be 4 over 3. So our total resistance is going to be what? 1.25 ohms, right? So now we know we've got 1.25 ohms in this circuit, which is going to be less than any of our values. So that, again, that always is reassuring. 1.25 total circuit resistance. And then we just multiply 1.25, right, using what? Well, voltage is equal to current times resistance. And we've got 6 amps, and we've got that multiplied by 1.25 ohms. And that's going to give us our voltage. So our voltage here is going to be 7.5 volts. So we know up here, 7.5 volts is the answer to that. Now, we can break that down a bunch of different ways. You really simply could just take, you could use Ohm's law again. And if we divided voltage by amperage, for example, 7.5 divided by 6 would give you 1.25 as our resistance value. So, again, not too difficult, and we should be able to start getting the hang of that now once we start combining those circuits, okay? All right, so let's do number 5 on worksheet 3, and that should give you guys a good general picture of what's going on. So let's add this in. Here we go, number 5. So this one, they're playing around their voltages, but again, not too much to worry about here. Looks like we got to solve for resistance 3 on here. So, kind of looking at these equations, sometimes what I do, it just helps me. I'm going to write in, I got 24 volts, right? That helps. And then I'm going to put in here that, coming out, I know I've got 6 amps coming back, right? And I know that I got 6 amps coming out, right, of this unit. And then in here, I'm going to write in that my first resistor is 12 ohms, and then my second one is 12 ohms, right? And then it looks like R4 is 6 ohms. I'll write that out here, but we don't know what R3 is. So the way that we may want to look at this is that we know that the total's got to come out to be 6 here. So we've got a resistor plus this other resistor over here. And we know that we've got to have so much current coming through here. So one way to kind of, I guess, I don't know if I call it cheating or not, but we know that at these points, right, we've got 24 volts, right? 24 volts. So based on that, we can kind of figure out the amperage, right? That'll help. So 24 volts divided by this would mean that there's what? Yeah, there's 2 amps right here. Which means if there's 12 here, there's 2 amps. Which means if there's a total of 6, we've got how much left? Well, yeah, we got 2 amps left here. That's it, right? So now we could, again, use kind of Ohm's law here, right? And I know that sometimes it's like, well, that was easy and you don't get it. But watch. So 24 volts, right, is equal to 2, right, times, which is our R3 plus R4, right, because that's a series circuit. So 24 volts equals 2 times R3 we don't know, right? And we've got this R4, oh, I'm sorry, I'm going to write that in. We know that this one is 6, right? Like this. So this would actually be written, if it was done correctly, it would say 2 times R3 plus 6. So now it's just simple algebra. I'm going to 24 is equal to 2 times R3 plus 12, right? I'm going to subtract 12. I get 12 is equal to 2 times R3. And then I'm going to divide by 2, and divide by 2, so R3 is equal to what? Yeah, 6 ohms. Which you may have already seen, because if we got 2 amps coming through, the total resistance. So that means that this one is 6 ohms as well, right here, right? And 6 plus 6 would have been 12 ohms, which means that's why there's an equal amount of amperage flowing through each branch. Each one has 2 amps, all right? Hopefully that was helpful, guys. Let me know if you have any questions. Always here to help.